Hello everyone, this is Professor Jason Kim. In this video, we're going to talk about how to organize the data, particularly by using something called frequency tables. And then from there, we're going to talk about the histogram and any other related topics. Since we are organizing the data and try to make a data into useful information, the information, so obviously we have to do some processing. And one of the way of processing is you are organizing the data. And one particular way that we use a lot is something called frequency distribution table. So frequency table is something called partitioning the data into class of interval of equal width and show how many data values are in each class, each group. The class or intervals are constructed so that each data value falls into exactly one class, one group. So in a table, when you make a frequency table, in this particular case, you have 1, 2, 3, 4, 5. You have 5 classes. So it's almost like you have 5 the rows. Now let's talk about how we are making this frequency table. So making a frequency table. Now we're going to actually do with a particular data later, but right now I'm going to just explain vocabulary and the steps that you need to take it. Okay. Number one, you have to decide how many classes, how many groups, how many rows that you want to have it. The number of classes is usually 5 to 10, and also usually given to you from the question or from the request. If it's more than 10, it's too many. Unless it's needed, they usually try to limit by 10. And again, it's usually given to you. Okay. And so usually that's the before that you do anything to make a frequency table. Number one, you have to decide how many classes you're going to have it, or they will give you how many classes they want. Okay. And then when they gave you data along with this request, first thing you do is rearrange the data in ascending order. So that's the smallest you have to write it first, and then getting bigger and bigger, and then the largest you write it at the last. So we call that one as an ascending order. So you have to rearrange it that way from the data they gave you. If data is already arranged in ascending order, then you don't have to do anything. If it's not, it will definitely help you if you rearrange the data in ascending order. So at least you will know what is the smallest value and what would be the largest value. So that's normally the first thing you do, rearrange the data, and that's very, very important. And then second thing you do is you find something called class width. Okay, class width is the difference between first number of first K class and second number class. So difference between that is something called class width. And from to that is also class width. From to that is the class width. So the difference between the first numbers, beginning numbers, are the class width. You can find this class width from this formula, the largest data value minus smallest data value divided by desired number of classes they gave you from the question. So this is largest, this is smallest. So it would be largest minus smallest divided by the number of class they gave you from the question. So that's how you find out class width. So that's how you find out the starting from. So usually the smallest number is the very first number from each class. And after you rearrange the data, largest to minus smallest, and get that value and divide by number of classes, that's class width. So you add that number from the first number, then you will get first of the second number. And then you add this class width to the beginning of the second number, then you will get a beginning of third number. And then you add again class width to the third number, then you will get beginning of third number, then you will get a beginning of the fourth number, and on and on and on. So that's why finding class width is very important, because it will tell you the beginning of each classes. You can figure it out, the beginning of each classes. Now, but one thing you have to be very careful, and many students getting wrong, is when you calculate the class width, if it's because we try to have the whole number for the class width, unless they say otherwise. We try to have an integer value, the whole number. So if you have like 2 as a class width, then class width will become 2. But if you have a 2.1, 2.4, 2.7, 2.9, like decimal numbers, then you will always, class width will become always the next highest whole number. So what is the next highest whole number or integer of 2.1, 2.4, 2.7, 2.9? 3. So that's how you find out. So we are not rounding off. We try to get a integer of a next highest whole integer. Okay? Also, you need to determine the range of the data or limit of each classes. So you have to find something called lower limit, low class limit, and upper class limits. You need this low class limit and upper class limit to create the histogram, the bar graph. Okay, so histogram is a fancy word for the bar graph, but you need that to create the bar graph like this, histogram. The class width is difference between low number between the lower class limit of the one class and lower class limit of the next class, which means that's the difference between first numbers of each class. The first number is the lower limit and second number is the upper class limits. After that, you count the data for each group, each class. We call that one as tally the data. This is one data belongs to the group, two that belongs to class or group, three you represent that, four. So this is a way of counting it. Five would be 1, 2, 3, 4 with the 1 in the middle. That's 5. 1, 2, 3, 4, 5. Okay. So 6 would be what? After you have 5, you get one more. 7 would be after you have a 5, you have 2 more. And on and on. So 8 would be 1, 2, 3, 4, 5, and 3. 9 would be 1, 2, 3, 4, 5. I'm sorry. I got one more. 1, 2, 3, 4, and 5, and 1, 2, 3, 4. And 10 would be then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So if you need to do the tally, that's how you mark it as a graphically. So when they ask to write a frequency of the class, or class frequency, that's the number of total tallies or total marks. And the next thing, you might need to find the midpoint. Midpoint is always low class limit, which means first number of that class group, plus upper class limit, which is the second number of that class, and you divide by 2. So midpoint, you're getting like averages of that group, or sometimes we call mean of that group. And we talked about class boundary, upper limit and the low limits. Upper class boundary is upper class limit plus 0.5, and low class boundary is low class limit minus 0.5. So let's say in each class, let's say the lowest number you start with, let's say 2. So let's say this is smallest number is 2 and largest number is 16. Then very first low class limit would be 2. And then after you find the class boundary, let's say class boundary was 5. Then class width. Then 2 plus 5 is 7, would be the first number we call, so this is low limit. And then because we set class limit as a 5, 5 plus 3 would be 12, sorry. And since the range was from 2 to 16, now the next one was another 5. So it will be 17 and on, if there is any class. And then once you find the lower limits, the upper limit would be just one before the number one before the one shorter than the lower limit of next class. So what is one shorter than 7? 6. So it's going to be 6 here. And on the second class, how do you find out the upper limits? Yeah, I got the lower limit by adding class width from the previous low limits. So how do you find this one? So always one shorter than lower limit of next class. So it will be 12 minus 1 is 11. And how do you find that upper limit of next class? 1 minus of next one, 17. So it's a 16. Okay. And from here, class boundary would be always one shorter than the low class, which is, I mean, 0.5 shorter than, you say 0.5. So 0.5 minus 2 is 1.5, and 0.5 more than upper class limit, which is 6 in this class, 6.5. And next one is always same as this, but again, 0.5 less than 7 is 6.5. 0.5 more than 11 would be 11.5. And 0.5 less than next class low limit is 12 minus 0.5, so 11.5 to 16.5. And 0.5 less than 17 is 16.5 to whatever. So always the upper class boundary are same as low class boundary of next class, like this. So we're going to do more practice on this later about these class boundaries. So the first group usually that we put in the frequency table is the limits, class limits. Second group of numbers that you put in, usually put in is class boundaries. And then we ask for the midpoint to find out where it is at. So you get an average of each class. So in this class limit, you have 2 and 6. So you add and divide by 2 because you're talking about two numbers. So that becomes 8 over 2, which is 4. And next one is 7 plus 11 divided by 2, which is 18 over 2. So it's 9. So the midpoint of first group is 4. So what does that mean is the middle portion is average of the first class in this particular case is, which is the middle portion is smack in the middle, which is average. It's 2 plus 6 divided by 2. And the second one is 9. So it shows you, all this midpoint shows you somehow where it's smack in the middle in that particular group or particular class. Okay. So all this small information help you to determine something. 12 plus 16 divided by 2 is 28 divided by 2 is 14, and so on. So that's how you find the midpoint. And the next one, if I continue, next one is usually the tallies or class frequency, in other words. So how many belongs to this group from the data you counted, how many how many data belongs to second class, you count it and write it down next to it. So if it continues frequencies. So let's say there are some number, let's say 2, 5, 7. So that means there are 2 data belongs to this class. 5 data belongs to this particular class. So you write it down. So it was 2, it was 1, 2, 3, 4, 5. Next one was a 7, 1, 2, 3, 4, 5 with a 2. But you don't have to write in tally unless you want to. You can just write in a number, which is easier now. And next one is relative frequencies. So if the total number was, let's say, 14 of them, so total data was 14 of them, relative frequency is fractional format out of the total. So there are 2 data out of 14. And then a lot of times we write this one in decimal number. So 2 divided by 14 is 0.5. So write down 0.15, sorry. And next one is, next relative frequency is 5 out of 14. So you divide 5 by 14, 0. Let's say, so it's a 0.350 something. So you round up by 2 digit two number after decimal. So it becomes 0.35. So a lot of times we express in 2 digit or 3 digit after decimals. Next one is 7 out of 14, which is 0.5. And then when you, if that was the last one, when you add them all, it should be 14 out of 14. The total would be always 1 or near to the 1. So sometimes we, because of the rounding off of decimal, sometimes we got 0.98, 0.99, or sometimes we got 1.02, 1.1, like that. So, but it's okay, as long as it's very close to 1, because the sum of all the relative frequencies should be 1. So you write down 1 in here, or 0.99, or 1.09, or 0.1, or something close to 1. So that's how you find the relative frequency. Okay. So now let's look at this example. They want to make a relative frequency table. And then in the question, say, hey, make a relative frequency table from following data with 4 classes. So they gave you how many classes you need. So what do you do when they ask you to make a relative frequency table? Well, first you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you make it as a n equal 18. The n is usually symbol that we usually use to letting you how many data you have in sample data. So n equal 18 because you have there are 18 data. So that n is the size of the data. And then another given information was the 4 classes. So class equal 4. So those are the 2 information that you have to have with the data. And then you rearrange this data in order. So you scan it. Oh, here is a 1, smallest number. So you write 1 first. Okay. And then you find that 2. So write. And 3. Write 3. Oh, here is another 3. So write 3. So not to get confused, once you choose it, you mark it. You mark like dot under it or cross it out. So in that way, you don't have to confuse yourself. Either you count it or not. And next one is 4. So this is 4. Sometimes you use the other one, 4, 4, the other cross out, and another 4. So write that. And 5, maybe I use wave this time. 5, 5, and 5. And then you have a 6 here, you have 6 here, 6 here, 6 here, 4, 6. And 7, and 7, 2 sevens. So I cross everything but 10. So here is 10. So it is very important that you rearrange the data in ascending order. Okay. Otherwise, dealing with the data is very complicated. Now, in first calculation you do is finding a class width. So what was the formula of class width? Largest number minus smallest number divided by number of class, which is 4 in this case. So largest number was 10, smallest number was 1, and the class was 4, so it would be 9 divided by 4. So you end up with 2.4. But the class width is not 2.4. Class width will be next integer, okay, if it's not integer value. So what is the next integer from 2.4? They say it's whole number, but it's actually next integer. So 3. So class width become 3. That means the difference between each class would be 3. That's what they mean. So what do you do after that? So you make a table. How many row that you have? They say 4 classes. So that means you have a 4 row. Because class means how many groups, how many rows that you have in a table. And what number do you start with? You always start with the smallest number, or sometimes close to smallest number. So the lower limit. That you start number with, you start with a 1. And upper limit. But before you look for the upper limit, once you find the very first low limit, you have to find the next low limits. Now, how do you find this? Well, you add class width that you just found. Class width, what we found was 3. So you add 3 from the very first number, which is the first data value. So 3 plus 1 is 4. So that means we're starting our low limit of the second class as 4. And again, low limit for the third class will be, again, class width was 3, so 3 more than 4, so use 7. And next one is 3 more than 7, so it's 11. So you find a low limit first for the groups. Okay, and then upper limit is usually 1 lesser than low limit of next class. So what is 1 lesser than next class? 4, right? So what is 1 lesser than 4? So low limit become 3. Okay, and then how they find the upper limit become 3. So how they find the upper limit of second class? 1 lesser than low limit of third class. So what is 1? 7 minus 1, 6. So any data 1 to 3 belongs to the first class, and any data from 4 to 6 belongs to the second class, and that was 7, right? And this should be 10. Okay. And usually very last upper class would be either belongs to here or there. Okay. So 1, 2, 3, 4, 5, 6. Oh, 3 plus 7 was 10. I made a mistake here. And there should be 9 then. I made a boo. I made an arithmetical mistake. And how do you find the very last one? Well, if I have next class, it would be 13, right? So well, less than 13, so it's 12. So that's how you find out the last one. I don't have next class, but if I had it, it would be 13. So 1 less than 13 is 12. So that's how you fill out your class limits. Now, next one is boundaries, the class boundaries. The class boundary is the low boundary, low class limit, and upper class limit. So they are all plus minus 0.5. So minus 0.5 from 1 is 0.5, plus 0.5 from 3 is 3.5, minus 0.5 from 4, which is the beginning of the low limits of second class, is 3.5. Notice that it's always have to match here. And 6.5, then it should start from 6.5 to 9.5 because 0.5 away from the plus 0.5 from 9 and 9.5 to 12.5. So when do we use this class limit? You use class limit for a histogram or bar graph. Now, the next one is, in this example, they have class limits. No, I'm sorry, the tally. You get frequencies. So how many data belongs to 1 up to 3? So you see, you count it from the data. You have 1, 2, 3, 3. So those 4 data belongs to this class limits. So you write down either 1, 2, 3, 4, or you write down 4 like this. At this particular table, I'm going to just write down the number. And next one is 4 through 6. Next class, next group is 4 through 6. So 4 through 6 is here, right? So how many members of data belongs to this category or this class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So write down 11. Okay. And how many data belongs to the other class, which is 7 through 9? 2. So write 2. How about 10 through 12? 1. And you double check, see if you miss anything by adding all this number, supposed to be same as the class size and 18. So 4 plus 11 is 15, 15 plus 2 is 17, 18. So, and it's 18, and you double check by adding all the frequencies, see if it's same as the size. And now we find a midpoint. So midpoint is usually the representation of that particular class. So you add 1 and 3 and divide by 2. So 1 plus 3 divided by 2 is 4 over 2. So your class limit was, no, I mean class midpoint is 2. So 2 become a representation of this particular class, which is average, or some we call midpoint. Second one is the lower limit 4 plus upper limit 6 divided by 2. So it's 5. 10 divided by 2 is 5. So first one is 2, second one is 5. Third one is 7 plus 9 divided by 2, 16 divided by 2, so you end up with 8. 8. Last one is 10 plus 12 divided by 2, so 24 divided by 2 is 22 divided by 2 is 11. So that's how you find the midpoint. So then next one is how to find the frequency, relative frequency. So relative frequency is, so I run out of the space, so I'm making another table. So it was 1, 2, 3, and there was 4 in frequency for the first one. It was 4 through 6, and frequency was 11. And 7 to the 9. This is a continuation of a previous table, which is 2. So that was the frequency. The last one was 10 to the 12 was 1. So this is continuation of the table. And then how do you find out the relative frequency? Relative frequency is fractional 1 out of total. So 4 out of 18, and this is 11 out of 18. This is 2 out of 18, and 1 out of 18 because total size was 18. So relative frequency is the fractional portion or decimal portion out of the total of that frequency. That's why they call relative frequency. So 4 divided by 18 is about 0.22. 11 divided by 18 is about 0.61. So you have to use a calculator if you want to be more accurate. 2 out of 18 is 0.11, and 1 out of 18 is 0.06. So when you actually divide 1 by 18, 0.0, actually. You get 0.55, 0.555, and continue. So what you do is usually round off by 2-digit number after decimal. So when you do that, you got 0.06. So that's similar to 0.06, 2-digit after decimals. So when you add all this, you end up with a 1. So you write down total equal 1. So in relative frequency, because they are based on total number, it has to be always end up with a 1 when you add the decimal numbers. Or when you add the fractional number, it should be 18 over 18. So what if you don't get 1? If it's totally off from 1, that means that you missed something or you made a mistake somewhere. but it's very close to 1, like 0.99, 0.98, or 1.01, 1.02, then that's fine. That's a good achieve between this rounding off things. Okay, so that's how you find the relative frequency. Then, in case they want to find out the cumulative frequency, cumulative frequency is like running total of each frequency. So once you have cumulative frequency is running total. So first one is always same as the same number, 0.22. And then you add with 0.22 with a 0.61 because you're asking for the running total. So 0.22 plus 0.61, you end up with 0.83. And then you add 0.83 with 0.11, then you got 0.94. And then you add 0.94, add with the 0.06, you end up 1. So cumulative frequency always end up with a 1 because the running total have to be same goal, which is 1. And then the way you draw the histogram is for the x-axis, you write down the class boundary, and y-axis, you write down its frequencies. So what was the first boundary? Class boundary was 0.5 to 3.5, right? Here, 0.5 to 3.5. Here, 0.5 to 3.5. So starting from 0, here is 0.5 to 3.5. So that's one bar, one boundary. And second one is 3.5 to 6.5. So starting from here, 3.5 to, that's the next one, 6.5. And third one was 6.5 to 9.5. So 6.5 to 9.5. And then next one was 9.5 to 12.5. So that's x-axis basis. And then frequency goes how high you go up. So 0.5 to 3.5 was 4. So 1, 2, 3, 4. Let's make it smaller because you have to make 11 later on. 1, 2, 3, 4. So 4. So you have to label them 4. So you go up to 4. And sometimes it's hard to see it, so you write down under it, like 4. That means you went up 4. Second bar goes to 11. So 4, 5, 6, 7, 8, 9, 10, 11. So so you go up to 11. So that's the second bar. And you write 11 there. So in that way, you go up to 11. Third one boundary was 6.5 to 9.5. It's 2. So here, and write down 2. So you will know, and I will know, and anybody will know how far you went up. And that 1. So this is the histogram, the bar graph. Now, what does this histogram or bar graph is telling you? It's telling you if I connect the midpoints of each one, telling you that how the data actually went. Okay, so based on this histogram, if I connect all relative frequencies, I can see the format is mound shape or symmetric, which means it's like, and it's symmetric means it's a mirror image to each other. Or sometimes it's like flat. Sometimes it's squared left. So squared left means you have a like tail in the left side. Squared right means you have a like tail in the right side. So squared is like tail. You have a tail in the right side. Bimodal means you have almost like two of the like mirror image things, two of the top like that. Okay? So that's how usually if it's significant usually by the histogram or relative histogram is telling how the data look like, where more things goes like that. So again, what do histogram or relative frequency histogram telling us? It's telling us that how the data is distributed. Is it symmetric? The data distribution is symmetric or squared or bimodal? Or is it if there is a outlier, or which data interval contain the most of data? So where the most of data is at, how the data spread out. Like the picture give you 1,000 words. That's why we are doing the histograms. We talked about, I just briefly say something about outlier. Outlier is a data that is different than normal. So let's say you have a data like this. But let's say one of the data is somewhere like here. That means usually very, very last or very, very first. This is, it's data is there, but it shouldn't be affect the mainstream of the data. So outlier is something is extreme data. So extreme data, we try to get rid of it to get like more accurate representation. So we name that extreme data just as outlier, and we usually take that off. Okay. So let's say you try to get an average salary of teacher. Let's say that one particular school, they makes either 40,000 to let's say 50,000 to $100,000 is the average salary. But what if the reason one teacher make extremely small amount, because it's supposed to be 50,000 to 100,000. Let's say somebody makes only 20,000, then that's outlier. Or somebody make $400,000 for whatever the reason, then that become outlier, because in average it should be somewhere between 50,000 to 100,000 to start, and somebody starting from $400,000, that means something is wrong. But if it was a valid data, we call that one as outliers. Okay? So that concludes today's class, today's video. I am going to, I want you to look at those the homework exercises. Those are the ones that you need to do it, and step-by-step solution of all the exercise at the end of the lecture notes. So try this on your own and then check your answer with the solution set at the end of your workbook. Okay, so this is the end of this video, and I will see you in a classroom. Be safe and be healthy. Thank you.